Hello YouTube! Today we look at all the upgrades and improvements I've made to my 3D printer, covering why you may want it and how I implemented each feature. So if your printer lacks any of these, you may consider doing the same, and this should give you some ideas on how to go about it. Most printers nowadays come with an adequate part cooling fan, but mine needed one. Without it, bridges and overhangs droop, and the corners and detail are all rounded over. You can print, but the quality can be poor. So I had to design one. Being new to 3D printing in CAD, I used Tinkercad for these first designs, because there isn't much of a learning curve to get started. It lacks the power of precision that pretty much any of the major 3D CAD programs have, but you can get the job done. The ramps board has a fan connector that can adjust the speed of a 12-volt fan, so more air is better, as you can always reduce the fan speed in your slicer filament profile if needed. There are two types of fans commonly used to choose from. Axial fans, like a standard PC fan. They move lots of air but don't generate much pressure. And then centrifugal fans, or blowers. They generate pressure but less airflow. The main thing you need is to get the air near the nozzle from all directions. In my case, I'm very limited on space, so I needed to duct the air over to the nozzle, and therefore I needed some pressure. So I chose a 70mm 12-volt blower fan. This works great, and after several revisions to the mount and ducting, it does all I need. I used a tempered glass plate for the print surface. There are a few things flatter than float glass. With a smudge of glue stick, just about everything sticks to it. But sometimes it sticks too well. So it's handy to pick up the plate and brace it so you can chisel the print off. I designed and printed some corner braces and clips to make it easy to remove the glass and replace it so it's secure and level. The bed clips are glued in place and work great. They also lift the plate just enough to fit the bed heater. I would say the bed heater is more of a nice to have than an essential for most printing, but if the print doesn't stick to the bed well, it fails every time. And a heated bed helps with this, so it's good to have. Also, it was cheap. $14 on Amazon for a 120-watt silicone heated bed pad. I stuck it to an aluminum plate that spreads the heat to the glass, and then packs the space between the wooden bed and the pad with rock wool for insulation. It adds about 2 minutes more to the print time to wait for it to come up to temperature, but usually it's worth it. Okay, this is one that you probably won't need, but the takeaway here is that if you own a 3D printer, you can customize anything. My original X-carriage was drilled and milled and whittled out by hand. The new one was designed in CAD and printed, so every hole and line was exact and square. I tried to stick to the wheels at first. That's the version on the left. But the wheels on rods just don't work. The rods flex too much. Perhaps it'd be alright on sturdy rails, but not on 6mm rods. The final version uses linear bearings, and that worked much better and increased my print quality. Now for the accursed Z-wobble. This was the most difficult upgrade and the most effective upgrade. My early prints had rings that matched the thread on the threaded rods I used for the Z-axis. It was bad. I'd used 6mm threaded rod, and it was a tad warped. Not much, but enough. I ordered more, 6 times. And all of it was a tad warped. So I finally broke down and spent the money on some 8mm Acme milled lead screws. This helped a lot, but I didn't get all of it. Instead of having a sharp peak every millimeter, I now had a lesser and much more rounded spanning each 6mm. The rods were straight, but there was still some wobble. To fix this, I made a floating Z-axis. The idea is that the turning of the screws should only be coupled to the Z-carriage's up and down movement. Any movement side to side or back and forth should be free. So the nuts that fit the Z-screws mount into plates that fit into a slot in each Z-carriage rather than mounting to the carriage directly. This is shimmed up with small grease sheets of aluminum so that there is very little play in the Z direction, but still some in the XY. It took some tuning and tinkering, but pretty much removed all of the Z-wobble in my prints. Auto bed leveling. This one should be considered essential. Manual bed leveling is a pain, and in my case, it just wasn't working. Oh, it worked well enough, but I didn't know what I was missing. My issue was a slight 0.5mm alignment issue in my Y-axis rods caused the bed to functionally have a bit of a saddle shape. It's almost impossible to see this or compensate for it manually. I bought a BL Touch and configured Marlin to use it, and to do auto bed leveling, and this was a huge convenience. Along with the bed visualizer plugin in Octoprint, I can now see what's going on, and the software can adjust for issues to get much better prints. So worth it. There are lots of tutorials already on setting this up, so I won't go into detail here. The final upgrade relates to the Pi4 with Octoprint and an LCD touchscreen. This made a huge difference, way more than I expected. The Pi Zero was underpowered and was causing issues that I didn't even realize until I upgraded. Adding a touchscreen LCD was also a huge convenience. However, since the utility and usefulness of this applies to almost any printer, I'll cover this in detail in the next video. So if you liked this, please click the like button, it helps me a lot. And be sure to catch the next one and subscribe. And until next time, thanks for watching.